Hey, welcome to Algebra 2 Easy. Today we are going to rewrite quadratic equations in vertex form. Just as a reminder, vertex form is a times x minus h quantity squared plus k. And h and k are your vertex. Vertex form is really handy when we want to graph equations quickly and easily. So let's take a look at example 1 here. We're going to start by grouping our like terms. So x squared minus 4x, since they both have an x, we are going to group those. You are looking to see if you have a leading coefficient other than 1. If you have a leading coefficient other than 1, we're going to factor that out. Here, our leading coefficient is positive 1, so we don't need to factor it. And we're going to leave it as x squared minus 4x plus some number. And then we have our plus 5 on the outside. Your job is to complete the square. We are going to create a perfect square trinomial. To do that, you're going to take the middle number and divide it by 2 and then square your answer. So negative 4 divided by 2 is negative 2, and negative 2 squared is 4. So 4 is the number that goes in that empty space. Now, math is all about balancing. So if we add a number inside the parentheses, we also need to subtract that number on the outside of the parentheses. So we're going to add 4, but we're also going to subtract 4. It's all about balance. Now we're going to rewrite our equation. We have x squared minus 4x plus 4, and then we have plus 1. As you can see, the plus 1 is my k value. We now need to rewrite this quadratic as a binomial being squared. So what two numbers multiply to give me 4 and add to give me negative 4? Well, that would be x minus 2 times x minus 2. This is why we call it a perfect square trinomial. Both of these factors are the same, so we can rewrite those as a binomial x minus 2 being squared. And then we have our plus 1. Now your equation is in vertex form. Let's try another example. Y equals negative 2x squared minus 12x minus 12. Again, the first step is group your variables. So I'm going to group my variables, and I am looking to see if my leading coefficient is something other than positive 1. It is. It's a negative 2. So now we will factor out that negative 2 and rewrite our problem. So negative 2 factored leaves me with x squared plus 6x. And then we have our minus 12. This is why we group first, because we don't want to factor anything out of that constant. Now the rest of the problem is identical to the one before. We're going to leave the negative 2 in front, and we're going to figure out what number do we need to add to this quadratic to make it a perfect square trinomial. And if we add on the inside, we have to subtract on the outside. We must keep our equation balanced. Now we'll take the middle number from our quadratic, and we are going to divide it by 2 and then square that number. 6 divided by 2 is 3. 3 squared is 9. So I'm adding a 9 inside the parentheses. So obviously I should subtract a 9 on the outside. No, that would be wrong. We're not actually adding a 9 here. We're adding a negative 2 times 9. Remember, we factored out that negative 2 at the beginning. It is originally a part of the quadratic, so we can't leave it out. So even though I'm adding a 9 inside the parentheses, if you factor out a leading coefficient, we now need to take that number and the number we just added and multiply those together. So negative 2 times 9 is negative 18. So we're actually going to subtract negative 18 to balance our equation. Because remember, it's all about balance. Now if we clean this up, we have y equals negative 2 times x squared plus 6x plus 9, and then we have negative 12 plus 18, because we have that double negative here we have to take care of. Y is equal to negative 2 times x squared plus 6x plus 9, And then negative 12 plus 18 gives me positive 6. So now we need to figure out what two numbers multiply to give me 9, but add to give me 6. If we factor that quadratic, we get x plus 3 times x plus 3. And then we have our plus 6 on the outside. And you can rewrite x plus 3 as x plus 3 quantity squared plus 6. Now you have an equation in vertex form. Have a great night.